Hey guys, it's Bobby and Mike from RevoPower. We've been seeing some comments lately of customers and commenters on our YouTube videos that aren't really sure about the durability or the waterproofness of our solar generators. So we figured, why not do a complete test to see how waterproof our Fortress solar generator really is. So Mike has a pressure washer, and let's put it to the test.
So I've got here an 1800 PSI pressure washer, and I'm just gonna go right for it.
There went the stickers.
Lost some stickers. All right,
Mike gave it a good spray down, so I want to give it a whack too. Let's see if it can take two spray downs. Right now I'm getting the fan. This is air inlet, so I'm trying to see if it can get up into that air inlet. There's a foam gasket in there. In the back, you probably can't see it, but these are the inverter mounts. We have rubber washers, metal bonded rubber washers holding the inverter on. In the front, we have 120 volt receptacles. We have PG7 cord grips right here, and the charge controllers are held on by these screws with bonded metal washers, metal rubber washers. Post terminals right here. And then we have the fan inlet right here. See if we can get some water to get in there. And then just the lid. I think Mike got pretty much all those areas too, so let's see how it looks. Well, everything's still on. That's good. The charge controllers are still on, you can see.
There's a little bit of water down there.
Yeah, there's definitely water down there. Luckily, we have weep holes in the bottom of the Fortress so that the water can all escape out the bottom.
Nothing really on the battery terminals.
Yeah, the battery terminals look like totally dry. The top's totally dry. The inverter's a little wet. And then you can see the receptacle backs. You can see right here, if you zoom in, the back of the receptacle has like a waterproofing. This is actually a rubberized 3D print. So it is flexible. So you can flex it. And so that's kind of protecting all the connections in the back of the receptacle. So let's see if the inverter, yeah, the inverter turned on. It's got the light on here in the front. The inverter switch is on the outside of the box, just so you don't have to open the box to turn on the inverter. So the inverter's on, everything's working good. So I don't think this was a good enough test, Mike. What do you think?
I think we should head for the lake.
Yeah, I think we should do something way bigger than this. Let's toss it in the lake. All right, cool. I'm excited.
I'm excited too. And just to fill everyone in, we tied in this rope so that we have a way to pull it out.
Yeah, we're not sure like if it's gonna float away or like how fast it's gonna sink or if it's gonna sink, but
I think we're gonna see a lot of bubbles.
Yeah.
I think it might be bubbling for like a few minutes.
Yeah,
just
probably
depending on how much water is going in at one time.
And we did make sure to turn it off. Like all the 12 volt stuff is still connected, but the inverter is turned off just because safety reasons.
Safety first.
All right, Mike, I'm gonna let you do the honors
Okay.
and we will stand back and watch. So
We gotta find the appropriate depth here. We're ready?
all right, Mike, she's all yours. That was loud.
Well, it didn't sink right away.
Oh, we forgot to grab the rope.
And it's floating away. Yeah. In hindsight, I probably should have held on to the rope.
Kind of reminds me of Titanic.
I think I'm gonna have to go in and assist it, if I'm being honest.
Yeah, it's floating surprisingly.
Because we
for a
came
long
out
time.
here to do this test to make this thing sink.
Yeah, we want it to sink because we want to show like fully submerged.
It is a lot more buoyant than I thought it would be.
Yeah,
It's not going down. There we go.
Mike's
So already
driving the
this
solar generator
This
now.
went from worst case test to manufactured test, because if you dropped it in, it wouldn't even sink.
a forced water
This is
test.
a forced submersion.
We put the zip ties on the lid because we were afraid the lid would pop off when we threw it, but
Clearly that wasn't really an issue.
yeah.
I wonder how long it's going to take.
That's a lot of air.
Judging how fast the air is coming out, which is not that fast,
I think it's safe to assume the Fortress can handle some rain.
really.
We already established that in the last test.
After all that, it still floats.
Well, we could probably just check it out now if you want, or
Try it now.
I don't know. What do you think? Fully submerge, or you might as
I
well
say we
fully
keep going.
submerge? Yeah, you're already
Well,
most of the way there.
We got to get it to the point where it's not buoyant enough to pop out of the water. Just
Needless to say, if you're using this on like a boat dock or something and it falls in somehow, it would definitely float.
this is the worst case of all worst cases.
Yeah, it really is. This is like
all right.
hurricane plus bad
The right side
intent
stopped.
person.
At this point, the right side kind of stopped bubbling. Should we call it?
Yeah, I think we can call it.
All right.
If you want, you can hand me the rope and I can try and like lift
Do
it
the
up.
assist.
Yeah.
Let's bring it a little more to the shore.
Dang, this thing's a beast.
Oh my gosh. There we
Oh
go.
my God.
Now we gotta wait just as long. Oh, check
So-
that out.
Yeah, you can
It's
see
draining out of the.
Oh, nice. It's
Out of the
draining out of
vent.
the fan. That's the air inlet. The low one's the air inlet. And then on the other side, this higher one is the fan. So that's where the air comes out. And it also has weep holes in the bottom. So I guess we can cut the
Yeah.
zip ties now, right?
Let's cut them. There we go. Wow.
Ooh,
This water's
it's
a bit
lot
murky.
of water.
Battery's now definitely wet.
Well, the charge controllers are still kicking because
I
the
was-
lights are on.
Just about to say that.
Let's check the
120
the USB.
receptacles got wet.
The USB-C. The USB-C is still lit up, so that's still working
With
You
water.
can still charge your phone. I would guess the
in-
12-volt socket. This is just like a cigarette socket. So that's all that stuff's still good. I think we should wait until all the water's drained out before we turn on the inverter. What do you think?
Probably just to be safe, at least so there's no standing water on the electronics.
Yeah. So the water, like if any water does get in, it's all just going to come out through the little, the weep holes are like 1/4 inch or so in the bottom.
I mean, at this point, we could
But
probably
like,
just
that's a lot of water.
dump some of it
Yeah,
to save
good
time.
point. Yeah.
I mean, I think we get the point with the how wet it is.
Man, I cannot believe how long that thing was floating.
It was pretty buoyant too.
It was like you had to force it to die.
Which side? Okay. So the weep holes are right here.
Yeah, there's one there and one on the other end.
There's one on the...
Just in case it's on an incline or something.
Opposite side with the bug screen on it.
Yeah. Yeah, they have a bug screen so the ants don't get in and make a house.
So at this point...
So I guess we can wipe down the...
Draining a little bit still, but not as much as when the vents were going.
I guess we can just make sure water's not in the inverter.
If we tilt it this way...
Oh, yeah.
It'll come out of the... There we go. Now it's coming out of the fan.
Yeah, it was coming out of the inverter.
Fan inlet. Or I guess it's an outlet in this case.
Yeah.
All right. That was...
But the reason why like it was so hard to force water in is because like that has a foam gasket. So like the fan and the inlet, they both have gaskets. So it's not like just holes in the box. So it really was pretty waterproof. Like it was like trying to sink a balloon or something.
So at this point, I'm going to give the 120 volt receptacle just a pat dry.
Yeah.
Just on the outlet.
What do you mean? You don't want to get shocked?
Don't want to do a hospital video next. And we brought this Dremel as a tool to try out. So if you could hit the inverter.
Actually, why don't you plug it in first and then we can turn on the...
Even smarter.
Push the button. Yeah, that way. Yeah. Cool. So it's off, right?
Yes.
Okay. So turn the inverter on.
And...
All right, the inverter. Uh-oh. The inverter's crying.
Uh-oh.
Oops. Ouch.
Should I hit the Dremel?
Well, the inverter didn't like that. It just turned off. Man. I wonder if we should... wonder if it blew a fuse.
That may have been what that was.
Smoke?
No smoke.
I noticed there was water coming out of it earlier.
Yeah, we didn't really get it fully dry. I didn't think we'd need to.
Dang. Try it again. Nope. Well, catch us next time.
We all learned something here today.
Catch us next time for another torture test. All right, so we just noticed something. We thought it was the inverter that died, but then we're looking and the charge controllers have turned off too. But these charge controllers are fully potted, meaning they're filled with silicone epoxy. So there's no way both of the charge controllers died and the inverter all died. So I'm thinking maybe there's an issue with the battery BMS, or maybe it should be hopefully something simple to fix. So I think we still have this towel because I don't want to give up on our baby that easy. We've been building these for a long time, and we have these in marinas and all kinds of applications. A lot of people use them in their garden for Christmas lights and stuff. All right, there went the charge controllers. So those are back on. So all I did was dry out these Anderson connectors. Probably wouldn't hurt to dry out everything a little bit. Oh my God!
Oops. Magic white smoke?
Yep. So I noticed the charge controllers were off, and I was like, wait, how's the inverter and the charge controllers off? And I was like, it must be a battery thing. And so I cleaned this, plugged that back in, and the charge controller's turned on.
Interesting.
Tried this and then plugged this back in, and it's definitely dead now.
That's the Anderson for the inverter.
Yeah.
But our battery's good.
The battery's good. Yeah, but I don't think we'll be hearing from the inverter again.
Dang.
Yeah. So maybe that's just a lesson not to throw your solar generator into a lake.
I guess so. Like and subscribe for more solar generator shenanigans.
Please do. For more torture tests. All right. I guess we're done, huh? Man, I'm disappointed, to say the least.
Yeah.
I don't know what I was expecting though, because like I was hoping for the best, but in reality, when you think about it, throwing an inverter basically into a lake is never going to come out good.
I knew the battery would be fine. I figured this charge controllers would be fine.
Yeah,
I'm with you. I don't know what my expectations were for the inverter.
Like all the 12 volt stuff was fine.
I don't know.
Yeah, the inverter, I mean, to me, it seems like it passed like 9 out of 10 tests. Like,
yeah,
could it survive rain? Yes. Could it survive a hurricane? Yes. Could it survive a hurricane and falling off the dock for like 10 seconds? Yes. But the test that we did was like drowning the solar generator.
The test itself was not
like we were forcing water inside.
That's not how you test water for a solar generator. That's how you drown one. Yeah.
Yeah. So
that's not even replicating a harsh scenario.
Yeah. It's like killing a solar generator.
Just to see. It's almost forcing death upon it, and then doing an autopsy to figure out.
So yeah, it didn't survive a murder.
Yeah, basically. That's pretty much the best way to say what the test itself was.
Like I'm confident, like I would say if it fell into the lake and we picked it up and put it back on the dock.
Right off the bat, you'd have, it seemed like probably 2 minutes to scoop it up out of the lake because I had to go sit on it.
You could go like swim out to it and pick it up. But yeah, like you guys see like how we always on the Fortress, the inverter is always at the highest point possible. Sometimes it's on the lid, but usually we try and prevent it from being on the lid because then it's just hard to like turn it on and off sometimes. Yeah, it's hard to open. Everything's plugged into it. So like you got a good 2 or 3 inches that water can rise up into that box before it even touches the inverter.
Mm-hmm.
So like however long it takes 2 or 3 inches to fill that box, like I'm trying to think of any situation where that would happen in the real world, where someone was not trying to murder your solar generator. Like it would have to be if you left the top off, I guess. Maybe not even then though, because if you leave the top off, the water comes in and goes out the weep holes.
I don't know.
Like how, like what real world scenario would be like that? It seems like if the top
wasn't on, it would never have even toppled. Like the way.
Oh yeah.
I kind of tossed it up when I threw it in, and it didn't rotate to the point where if the top was off, water would flood in. Point. It would probably just sit there like a canoe and just float.
Well, but it does have the holes in the bottom, so yeah, it would float for a long time.
Either way, I think you'd have like
until it sank.
At least a minute, probably 2 minutes to pick it up.
Yeah.
So it's beyond.
So like the premise of this video was to show like us throwing the Fortress into a lake. And I think we went a little too far because
the idea
we threw it into the lake and then we pushed it into the lake.
To do the most extreme water test possible.
Yeah.
I think I didn't think I would say this before the video, but I think we went too far with how extreme it was. It was a little much.
Yeah. I do too. Yeah, like
it was nowhere near realistic. That would just never happen.
Yeah, it really, like if you think about it, like testing something, like if you wanted to test how fast your car could go, this would be like putting rocket fuel into it, going to the top of a hill and like pushing it and then just full throttle all the way down. Yeah, of course something's gonna break.
Yeah, it's more like performing a solar generator murder and then trying to do an autopsy.
And then wondering why it doesn't work anymore.
In the autopsy, why did it die? Okay, well, let's see what happened to it again.
Yeah. But the thing that makes us different at RevoPower from a lot of the imports is that like you could safely, like I am sure of it, you could throw it in the lake, pull it right out and it would still work fine.
Yeah,
like no other solar generator can do that.
Had we even left it there 20-30 seconds and pulled it out,
yeah,
the water wouldn't even at that point be halfway to the inverter.
Yeah, like I bet you if you tossed a Blue Eddy or a EcoFlow, it'd just sink like a rock and probably just break immediately. Yeah. Those things got holes all over them and like...
Yeah, that would be a good test to do, to throw one off the same dock.
An expensive one too. Very expensive.
That one's not really recoverable.
Yeah. So it's disappointing, but like, yeah, I don't think this is a pass or fail test. I think this is a test with many layers, and I think we passed 9 out of 10 layers, and the 10th layer would be like perhaps some kind of military application, or maybe even like an underwater solar generator. Like we're one level away from being an underwater solar generator. Like, I mean, if anybody wants something like that, we would love to build. We love building specialized custom solar generators. Mm-hmm. Not necessarily one-offs. Like we love one-offs, but like we can also do like runs of customized stuff. We can do private labeling, put other companies' names on the product. Like we just want to build the best solar generators that you can buy. Like that's basically our motto. And so like this test proves that the Fortress solar generator is very waterproof, but it also proves we have room to grow too. So
yeah, it's informational. I think we probably both would have guessed the weakest link.
Definitely, yeah,
would be the inverter.
Yeah,
but
yeah, inverters, they just have a lot of electronics in them. Like you were saying off camera, like they got 2 transformers, and then like they have all those, it's like a PCB with all those components, and like the inverter manufacturers, they don't like to do the full potting like the charge controllers, because they want to have airflow over all the components to keep it cool.
Not to mention, if you added up all the surface mount components from both charge controllers and the BMS on the battery, the inverter alone has like more than double all of those combined.
Yeah, that's a good point.
It's just a lot of components.
That's a good point.
Numerically.
Yeah. Yeah, it's a lot of components. Yeah. And the other thing is like it's high voltage ACs. Like things are a little more finicky when you're talking about 120 volts AC versus 12 volts. It's like 12 volts, like so tried and true.
12 volt and the terminals are roughly like 8 inches apart versus a surface mount transformer. The terminals are
everything's all close.
At most an inch apart, but probably a millimeter apart.
Yeah. So. Yeah, and it's not like we just half-ass like, oh, let's throw a solar generator. Like we did our due diligence, we did our homework.
Hey, I was testing the resistance of the water.
Yeah, Mike even measured the conductivity of the water.
So about it was 150,000 ohms at roughly a foot apart with the 2 multimeter probes of that lake specifically.
So that makes sense why the 12 volt stuff was still working.
Yeah, I mean that would be like a parasitic like 1 watt or
less
than 1 watt. So the battery, even fully submerged, would be fine. Charge controllers, again, fully potted, they would not even see any of that.
Yeah. So yeah, I mean, I would consider it an overall pass, I guess, if it was a pass or fail, with room to grow. And a reminder that like whatever applications are out there, like events, I mean, we can talk a little bit about some of the applications for this product because it opens so many doors to be waterproof. Like you don't have to worry about like rain. Like here in Houston, sometimes it'll be like sunny and then like 5 minutes later it's raining. And it's like, no.
Yeah, the pressure washer test is more extreme than a hurricane. I mean, we've both seen a few
we were like
hurricanes.
trying hard to get water in, and man,
a hurricane has got nothing on.
Yeah, there was barely any water got in. That was a good test.
So
yeah, like
there's that. So yeah, you're
boat
definitely
docks and
good.
marinas, I think would be perfect. Like
Yeah,
anybody that has a boat lift or something like
boat
this.
slip.
This Fortress only has a 1,000 watt pure sine, but like a boat slip would probably need a bigger inverter. But a lot of customers have bought the Fortress with like a 3,000 or 4,000 watt inverter for boat slips and stuff at their marina. I guess a lot of people have like refrigerators and lights and stuff.
Yeah,
and
some with TVs.
Like if you want it to be bulletproof, the 12 volt setup is bulletproof. Like that survived the murder. So like if you wanted a bulletproof solar generator, you could get like a 12 volt fridge. They make those 12 volt lights. They make those too.
TV
the USB-C was still working.
TV would be a bit tough, or maybe I'm just not as familiar with TV.
Yeah, I mean
DC
anything that
voltage.
uses a 12 volt socket, like cigarette plug, would still work fine. Like that whole part of the solar generator was good.
Yeah,
it's just 120 volts is always finicky. Everybody knows that. Like at their house, there's circuit breakers and stuff. So yeah, I mean, it's disappointing, but it was a fun test. It's always good to test our products to the max. I mean,
very extreme test.
Yeah.
And we're going to learn more from the autopsy of this inverter. And
yeah.
I would guess.
I like how we act like it's a human.
I mean, its death was similar to that of the humans.
True. Drowned.
Yeah.
But yeah, it is
learning experience, and you get better from learning. So
yeah, definitely.
We got to either do a different torture test, or we got to up the ante.
We're going to have to
we're gonna
step
improve
it up.
And when we improve, we're going to have to step up the torture test.
Yeah, we are, because like we love making our products better. Me and Mike are both engineers, so like we love improving products, especially on the technical side. And so I think we're gonna have a lot of fun improving this solar generator. I don't know if it'll be very practical because the price usually goes up with more waterproofing. So it might have to be like a separate solar generator. Like I was joking earlier, but it might have to be like an underwater solar generator. Like,
I mean,
for a weird application.
If there is, I guess, really anyone that needs that application, we can do it.
Yeah, because anything that can survive a drowning,
we now know
should be an underwater solar generator.
Everything except one component survived the drowning. So
yeah,
after we've pinpoint exactly what on the inverter failed, I mean, we can make this to where it won't fail a second time.
Oh yeah. Yeah. Americans landed on the moon. We can make this
guarantee
totally waterproof.
By take 2, we could make it survive a drowning.
Oh yeah. Yep.
But again, yeah, it depends if anyone needs that application. But if not, I mean, it would survive way more than a hurricane.
Yeah. Oh yeah. Hurricane would be like nothing for this thing. So yeah, we would love comments from people. Like we always love hearing from customers. We've been doing this a long time, and we're always looking for niche markets because the imports fill in a lot of these markets, and then, you know, it's just impossible for us to compete. So we love the waterproof world of like boating and outdoor, like 24/7 living outdoors solar generators. The Fortress is available with battery warmers for cold climates. It's got cooling. We designed all of our cooling stuff here in Houston. So like Houston summer sun on a black box usually gets really hot. So we've already done all that testing.
Temp controlled fans, everything.
Yeah, temp controlled fans. So we love hearing from customers, whether even if it's not like a request or anything, just tell us how we're doing. Yeah, any kind of feedback. Yeah. So share this video and laugh at us when we when we explode the inverter. And we'll see you guys next time on the next torture test.
Part 2.
Part 2.